Welcome to Better Fit e-learning platform. I still remember who I am. My name is Edo. So this class is specifically for SS2, but SS3 can also have this class as their revision class. So this week we are treating, we are still on handling sulfur and its compounds. And one of the compounds formed by sulfur is tetraoxosulphate 6-oxide. Tetraoxosulphate 6-oxide, that's the chemical formula there, H2SO4. Tetraoxosulphate 6-oxide. Now, here, tetraoxosulphate 6-oxide is a widely known chemical compound with various functions, various uses. That's why we say that it's widely known. And it is actually manufactured by what? Contact process. It is manufactured by what? Contact process is there. And the main reaction in this process, this contact process, is the catalytic combination of sulfur 4 oxide and oxygen to form sulfur 6 oxide. So which simply means that the industrial preparation of sulfur 6 oxide, leading to the final, product, which is tetraoxosulphate 6-oxide, is through contact process. So the first stage is the reaction of sulfur 4 oxide with what? Oxygen. So it reacts with it and it forms sulfur 6 oxide, SO3. It forms sulfur 6 oxide. That's the chemical equation, equation of reaction on the board. Sulfur 4 oxide reacting with what? Oxygen. That's the first stage in the contact process. Hope you are getting me now. That's the first stage in the contact process. Sulfur 4 oxide, reacting with what? Oxygen. Excess oxygen to be precise here to form a sulfur 6 oxide. So now there is soap in a dry air, or simply by roasting sulfide ore, any of the sulfide ore. That is how sulfur 4 oxide is prepared. Now this is the chemical equation of reaction where sulfur is being burnt in air to form sulfur 4 oxide. So it will interest you to know that this is the first stage in the industrial preparation of tetraoxosulphate 6-oxide by contact process. This is the first stage. Are you getting that? So now the industrial preparation by contact process. This is the diagrammatic representation of all the processes or steps involved in the industrial preparation by what? Contact process. Like I told you before, this is the first stage. Now sulfur now reacts with what? Oxygen to form sulfur 4 oxide. That's the first stage. Hope you are getting it. Sulfur reacting with what? Oxygen to form sulfur 4 oxide. Now this same sulfur 4 oxide, to further get sulfur 4 oxide, sulfur 6 oxide from sulfur 4 oxide, what do? You react it with what? Excess oxygen. Yes, you have to pass through this sulfur 4 oxide through excess oxygen. But in this stage, something must be involved. For you to be able to get a good yield of sulfur 6 oxide, when you are now passing the sulfur 4 oxide through excess oxygen, for you to be able to get a good yield of sulfur 6 oxide, you must introduce a catalyst. If not, you will not get a reasonable amount of this sulfur 6 oxide. So to get a good amount or good yield of this sulfur 6 oxide, what do? You bring in a catalyst to speed it up, which is vanadium 5 oxide, V2O5. Vanadium 5 oxide. Yes, it's a very good catalyst for this process. So when you now involve this catalyst now, you will find out that the reaction between sulfur 4 oxide and excess oxygen will now lead to the formation of sulfur 6 oxide. Now by the time you now get to this stage, then what do? You get what? A chamber containing concentrated tetraoxosulphate 6. You get a chamber containing tetraoxosulphate 6 where the sulfur 6 oxide will also react with what is inside the chamber, which is tetraoxosulphate 6, leading to the formation of what? Oleum. H2S2O7, leading to the formation of what? Oleum. That's an oleum there. I told you last week that oleum is simply what? A fuming a fuming tetraoxosulphate 6. Yes, it's bringing out fumes. Are you getting that? So don't mistake your oleum with tetraoxosulphate 6, though is a step to the final stage of the industrial preparation of tetraoxosulphate 6, acid by contact process. So it forms what? Oleum. Once this oleum is formed, the next thing is for you to add water to the oleum. Once water is added to the oleum, it has to be in excess too. Once water is added to the oleum, you get your what? Tetraoxosulphate 6 acid, which is our final primary target product. And you getting an H2SO4 is this tetraoxosulphate 6 acid. So you can see that this is the processes, steps involved during the industrial preparation of what tetraoxosulphate 6 acid by contact process. So it's only one stage that involves the initiation of a catalyst, which is the stage where sulfur 4 oxide will now react with what? Excess oxygen to form what? Sulfur 6 oxide. So study this contact process very well. You will know that it's very interesting. So I think this question came out last year. NECO question came out from this place that they should they should bring out, outline the steps or stages, processes involved during the contact process of the preparation of tetraoxosulphate 6. Try to get your past questions. NECO is there. Hope you are getting. These are the steps involved. So now let's move over to the physical properties of this acid we are talking about. The physical properties of this acid, which is tetraoxosulphate 6 acid. So tetraoxosulphate 6 acid is not an acid that you should play with, except when diluted. When diluted, it's okay, But when it is raw, there is nothing you can do about it. So you just have to be, because it will not give you a signal. It will not give you a signal. It does not bring out fumes. That's why they normally regard it as a vitro oil. It looks like oil. It's a viscous liquid. So let's see how it goes, the physical properties. Now, tetraoxosulphate 6 acid has a great affinity for water. Yes, it is true. Yes, it has a great affinity for water because among all the three strong acids that we have, tetraoxosulphate 6 acid, hydrochloric acid, and even triazole-95 acid, tetraoxosulphate 6 acid, H2SO4, is the strongest. Why? Because the degree of ionization is very high. It has 2 degree stages of ionization. Now, tetraoxosulphate acid has a very great affinity for water. You have to pour more water. You have to dilute the tetraoxosulphate 6 acid by simply pouring more water to make it diluted, because it is still raw. Now, it is hygroscopic in nature. Yes, tetraoxosulphate acid is hygroscopic in nature. Why do we say it's hygroscopic? Because it has the ability of absorbing moisture from the atmosphere. That is what hygroscopic substance. That's what they do. Yes, that's their function. They don't do any other thing. They absorb moisture from the atmosphere, usually diluting themselves, by volume. So it is hygroscopic in nature. Now again, it is very corrosive. Yes, it has to be corrosive because it's strong acid. Yes, it's true. All strong acid are corrosive. Very correct. So tetraoxosulphate acid is corrosive, and also burns the skin when it comes in contact with it. Yes, it's a very strong acid. Please don't practice this, it's bad. Try and if you pour a little amount of this tetraoxosulphate acid, raw one, once it touches the skin, what happens? It eats deep into the skin by simply dehydrating the water content in your system, so making it a very bad acid. I hope you are getting it. So it's not something that you should joke with. Tetraoxosulphate acid is very corrosive and very strong acid. So when it comes in contact with the skin, it burns it and eats deep. So again, it is also called vitro oil. Yes, it's a viscous liquid. Tetraoxosulphate acid is a viscous liquid. It's called a vitro oil. Sorry to say it. When I was teaching the last year set, I told them that tetraoxosulphate acid looks like a granite oil. Horuru, please, it's not a granite. It has a granite color. You normally see it's vitro oil. I hope you are getting it. It's a viscous liquid, so it's vitro oil. Now let's move over to the chemical properties of this same acid. Chemical properties of this same acid. Yeah, there's so many chemical properties. The first one is that the dilute acid is a strong diabazic acid. Why is it diabazic? Because in the compound, there are two atoms of hydrogen that can be, completely replaced by metals, probably group 1 or group 2 metals. So, and again, it ionizes completely. Yes, that is what strong acids do. They ionize completely. Your triazonitric acid, your tetraoxosulphate acid, even your hydrochloric acid. Those are the three major strong acids that we have. They ionize completely in water. That is why we call them strong acid. Hope you are getting me? Strong acid. So it has two stages of what? Ionization. These are the two stages. The first stage is that you engage it, you react it with what? Water molecule there. The tetraoxosulphate acid being reacted with water there to form H3O plus, an aqueous solution as hydrosodium ion. Hope you are getting me? And with the formation of this anion. So it does not end there. This last product now comes in here to end the last stage of ionization by simply what? Engaging it again with water molecule, which is the final stage of the ionization, to form H3O plus hydrosodium ion with the formation of tetraoxosulphate ion, SO4 2-. It's an anion. Yes, it's an anion, and it can be tested for in the lab during qualitative analysis, the one we call salt analysis. Hope you are getting me. So that is how it is. There are other chemical properties which I did not bring, which of course I will go to take in my next class. We are going to be talking about the dehydrating tetraoxosulphate acid being used as a dehydrating agent. Are you getting it now? And again, tetraoxosulphate acid, reacting with metals and reacting with what? Base, and again reacting with triazocarbonate 4. What are the products formed? So the areas. Thank you. I hope you have digested this topic. That is what I do here. I bring out the main points. You don't need to read everything. The major points that you need for your exam is what I will normally bring out. So I'll see you same time next week on the same platform. Remember, blessed.